Okay, so continuing on, Chapter 3, we are really focusing in on slope-intercept form of a line today. We talked about it in the last section. We said that it was typically the more preferred version of a line, and so because of that, we're going to go into a little bit more depth, and we're going to look at how we can, number one, graph with it, more so than just the plotting of points that we did in 3.1. This is graph using slope-intercept form. Then number two, we're going to do some work with the equations themselves. And then finally, we're going to do a little bit of problem solving. Remember, problem solving is our book's secret code for word problems. So just a little reminder, slope-intercept form of line, y equals mx plus b. M is the slope, 0b is the y-intercept. So we're going to start here with graphing by using slope-intercept form. So the instructions say graph the following lines without plotting more than 2 points. So I'm going to give myself some axes. So the first thing I want to do, because we're going to graph these on the same set of axes, is look at this in slope-intercept form. Part A is already in the right form, so we just need to move the 2x over by subtracting, minus 2x plus 3. So my two intercepts here, if we look at this, this is m equals 1/4, and we have 0, negative 3. This one is m equals -2, and we have 0, positive 3. So I know in the y direction, I need to go at least up to 3 and at least down to -3. Now we're going to go a little bit further. We're going to 1, 2, 3, 4, 5, 6. 2, 4, 6, and 1, 2, 3, 4, 5, 6, -2, -4, and -6. Now on the x, not sure how far we need to go out until we get into the graphing, so I'm just going to match scale here to make it look good. 2, 3, 4, 5, 6, 7, 8, 9, 10, 12 seems like plenty. 2, 4, 6, 8, 10, 12. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, -2, -4, -6, -8, -10, -12. So now we can go into plotting. So I will graph both of these in two different colors. We'll start with A. So if we're only going to plot 2 points, we obviously want to use our y-intercepts. So 0, -3. And then our slope is 1/4. So that means we're going to go up 1 and over 4. There's the 2 points that we have. And I can connect the dots here to make our nice graph of the line. There we go. So our points are 0, -3, and this was up 1 and over 4, so this is going to be 4, -2. And this is line A. I'll just label it as A since we're graphing A and B on the same set of axes. And then switching colors here to line B, we have 0, 3 right here, and our slope is 2, which means we're going to go up 2 and over 1. I'm sorry, our slope is -2. So we're going to go down 2 and over 1, like this. And then we'll graph this line by connecting these dots. And we'll label. This was 0, 3. And this one is 1, 1. And this is line A. So when you're graphing with slope-intercept, this is essentially graphing using slope. The point that you plot is your y-intercept, and then you use your slope, rise over run, to get the following point. So there's not too much new here, just a different type of question. This is what is meant by it. So in the next example here, we're writing an equation of a line whose y-intercept is given and a slope is given. So this is being able to take information and put it into slope-intercept form. So we have y equals, slope is 2/3 x, plus b is -7. And it's as simple as that. Just take the information and translate it back into an equation. Got a couple practice ones for you to try out. And now this is where we want to get to the meat of this section, and that is our word problem. So the adult one-day pass price Y for Disney World is given by Y equals 4.717x plus 80.91, where x is the number of years since 2010. So we're going to first use this to predict the ticket prices in 2025. So the first thing we need to do is figure out, what are we asking here? Well, we are talking about the year 2025, and x is the number of years since 2010, so this is 15 years later, which means we're plugging in 15. So we're doing y equals 4.717 times 15 plus 80.91. And this is, plugging it into the calculator, is 151.665. Now, as we talked about in the first section on word problems, every word problem, the answers need to have context. So what is this? Well, this is a y value. Y is price, price in dollars. So dollars get rounded to the second decimal. So we know that this is $151.67 in 2025. That's how much it's going to cost by this model to go to Disney World in 5 years. Now, in reality, that's probably more like 2 years away for us. But this is a model that was come up with a few years ago. So in part B, now we're interpreting the pieces of our slope-intercept equation. What does the slope of this equation represent in this context? So we can rely on our definition of slope from the last section. It's the rate of change. So this is rate of change, rise over run. That's dollars is y. So we're thinking delta y over delta x. Delta y is change in dollars over change in years. So that means that our slope is the amount of dollars the price goes up each year. That's the full context. Dollars, the price goes up each year. And then in part C, we're interpreting what the y-intercept is. And the y-intercept represents when x is 0. So if x is 0, x is the number of years since 2010, we get y equals a number. That's the price in 2010. That's how we interpret it in this context. So these are the kinds of things you want to be thinking when you're working through the problems in this section. Your slope is your rate of change. So you need to think about, what is your y measured in, what is your x measured in, and then interpret that in something that makes sense in that context. Your y-intercept is always your starting value of whatever your y is measured in. Okay, a bit of a short one here. That is the end of 3.3.